the GAN model. So in the deep learning, so basically what is a GAN model? GAN is a generative adversarial network. It is basically a neural network that help to generate a new data, or we can say help in many domains in medical imaging and other domains like self-driving car, and a lot of domain for image restoring, image enhancement, and many domains. It is really popular model in this era. So basically how the GAN works, so I'm going to uh, explain the theory, and then we will go ahead and we'll try to run some basic example of the code. So here you can see how the GAN works. So in GAN we have two neural networks. One is called discriminator and the second is called generator. Like two neural network, or you can say the two convolution neural network. If we are working with some imaging data, so it's mean that we need convolution neural network that convolve some filter on the image. So how they work, the discriminator and generator, they are the two model that help and play a min max game with each other. So the purpose of a generator is to generate some sample from some unknown distribution. If you can see, here is the generator model, here is the discriminator. The generator generates some sample from unknown distribution or any kind of distribution, latent sample or a z distribution. So and generate some data like this one, sample and a fake data, and pass that data to the discriminator. The purpose of the discriminator is to classify either the sample that a generator generate is a fake or a real. So if discriminator is classify well, it's mean that discriminator is good. If the generator is may try to generate a sample that is more looks like a real sample, it's mean that generator perform well. So yeah, the main objective is to design a model, a generator that perform well and try to make a fool to the discriminator. So here you can see amnes data set, that basically the discriminator is trained on the real data set first. First we train the discriminator train the real data set, and then generator will generate some data from unknown distribution and try to make the fool to the discriminator. If the generator successfully fool and the loss will be generator minimize the loss, it's mean that the model is well trained. So where we can use, I'm giving you some example. Let's suppose if we are going to generate something like the example is basically, if we are going this help us in data augmentation, we can use in data augmentation. We can also use in image enhancement, image restoring, image classification. Generator is also some example can be used for image segmentation. There is a lot of things, image translation, face swapping, deep fake. There is a lot of ongoing example, real-time example there. The generator perform very well, and it's still performing good and use and a lot of where if you can see here, image restore, like let me write. So you can see here how a generator perform well. Here is an example of the generator. Here is the image that is looking very bad, and the generator results are really good. So you can see image restoration, image also background like black and white to RGB GAN image. You can also use here black and white to RGB image. I'm gonna open an example. If you can see, again help here, generator and adversarial network. You can also use to in different example image translation. You can use in image translation. You can use in like so so you can see an example of image translation here, how the GAN model is perform well. Cyclic GAN, there is a lot of GAN that available. So image translation means if we have some animals with like zebra, we can translate into, here is a good example. You can see in this picture how the GAN perform well to translate some animals into the other animals, and nobody is gonna judge it. So here is just, some example. So let's dive into the code, how the simple code is work. So I already wrote a code, so I'm gonna run in a notebook. So here is, I'm just opening a notebook and name it GAN model. So I'll just gonna copy some my code, and yeah, here I'm just gonna copy step by step. So first of all, we need to initialize some libraries. So I'm gonna copy and paste. So OS to access the directories or data in computer or machine, or so this is to perform some array operation. We use numpy dot perform arrays addition and multiplication. Obviously, when we work with the images, the data we get and we have, we can say it's in the form of arrays, some values in 2D arrays, 3D arrays, and the tensor. So here is to visualize, we use matplotlib, and tqdm is used for using the progress bar, like it's showing some progress bar in percentage. And here is the keras libraries that we need, keras function that we need in to build a generative GAN models. So I'm just gonna run this one, and if it will take some time. So star means it's running this cell, and you can also see the icon here. So I got an error, so I'm gonna solve this error. Sometime if you receive an error, it's mean that your TensorFlow version is different. You have to uh, you have to upgrade your TensorFlow version. So here I got an error in this. Let me try TensorFlow dot, if I gonna write something like that, and TensorFlow dot, I'll have to check. And so we were trying to solve this error. If you can see here, so we are getting this error. So it's mean that this function is no longer available under this uh, layers dot advanced activation. So it's mean that if we remove this one, so when we run this one, so it will automatically not show any error. So after importing the libraries, so let me write it over here. First of all, need import and then we will mark it as a heading. So after that, so when we run this one, so the next step is to prepare our data set. So up to here, so if you can see here, so I just copy the code. So np.random.seeds, it's mean that, so whenever you run the code first time, it will show you some results. Whenever the next time, if you're gonna run this code, it will show you the same result, because you're just using the seed value same. It's up to you the value. You can use any value here, you can put 20, 21. So make sure every time the value will remain the same, so it will give you the same results every time when you run the code again and again. So it will give you the same results. So the dimension of the random vector we choose 100. So here we are going to load the data set. Which data set we are using? If you see here, so we are calling amnis dot load data. So basically the built-in data set that we are going to use is, if you can see that it's come under the package of under the package of keras. You can see here it's come with the keras. So we are loading that data set in here. We make a function, we are loading the data set here, and then split the data set into 10 and test, and then normalize the data set. So you can normalize the data set between, like if you between this value, basically minus 207 and minus 207, it's up to you. If you're gonna use divided by 2 to 5, it will also be correct, like divided by something, some people use divided by 2 to 5, something like that. So it's basically I have, it's defining that if you're going to use 127 half and something like that, it's mean that you're using unsigned integer versus signed integer. So means this is basically I'll have to check, but it's basically unsigned integer or maybe the signed integer, and some value if you're going to use, it's mean the signed integer. So you can use both methods. Unsigned integer, if you show your data set is unsigned integer, or maybe signed integer 8-bit or something like that. So normalize that data set, normalize into minus 1 and 1. If you're going to use this one, it will normalize into minus and 1, and other, if you're going to use this one, it will normalize between 0 and 1. So it's up to you, does not matter which things you are going to use. Then reshape the data set. So here if you can see, after receiving that data set, we are going to reshape that data set into one value 784, like 60,000 images into 784, reshape in one vector, and then return the training and test data set. So if I run this one line, so you can see it is downloading that data set from here, and then showing me the output of data set that we are calling the shape of the data set. So after this one, so we're gonna call an optimizer. So in this example, we are going to use atom optimizer. You can use sgd item. There is a lot of optimizer, you can choose whatever you want. So I'm gonna run this function simply, and then after we are going to create a generator. So here is the generator. So you can see here, how does the generator work? So basically using a sequential method, so we are trying to build a generator, sequential and generator, and add some layers with the units of 256 main in, and the input it handle dimension that we defined previously here, and then Ricky Relu, if you want to use the Relu and Ricky Luri, these are the activation function that helps to remove the non-linearity in the data. And then the dense layer is used. Basically if you see here, we are going to use a neural network I was talking in previously. So the GAN can be a neural network, a convolution neural network. So in this case, we are using a neural network. We are not defining any convolution layer here. So you can see here is a dense layer with 256 neurons, and the next one is 512 neurons, and the Ricky is 20%. The third one is 1024, the Ricky is something like that, and the last layer with a unit of 784 with the activation is 10H. So if you see here, our last layer required 784 neurons, and then so the generator.compiler, we using a last function of binary cross anotropy, and optimizer is that we define here as a function. So we can, when we run it, it's just simply run the code. So after defining the generator, so we can say generator model here. So I'm gonna make it as a commit. So after that, I'm gonna make or call a discriminator model. So here is the code that I'm going to paste, and here I'm going to write it discriminator. So the discriminator is also similar, but the thing is discriminator will gonna discriminate the things into fake or real. So it's mean that, so if you are going to define the discriminator, if you can see the difference, first layer we are defining 204 because the input of the discriminator is the output of the generator. So if you see here, so the input of the discriminator is output of the generator. So what the output generator generate, it will gonna be a input of the discriminator. So it's, if you see as a generator, the generator last layer is 784. It means that 784 will be a input of the generator with the neuron of this one discriminator, not the generator. And then we're defining the layer, and dropout means 30% neuron that we are going to drop. So then we are defining the next layer with the leaky relu and dropout, and the last layer with the dropout then. And if you can see the last layer, the unit defined is 1 and activation is sigmoid. So because why? Because in our last layer we have two classes, either fake or a real. So you can see here sigmoid or a softmax. Like if you gonna use a sigmoid, it's mean that it's differentiate the things into two classes. The value greater than 0.5 will consider one class and less than the other class. So using sigmoid with the unit 1 means 0 and 1, it classifies some things between 0 and 1. So again, the loss function is binary cross entropy and optimizer is this one. So I'm simply gonna run this cell, and after that here is generator. So here is, so the thing is that when we define the generator and discriminator, here is we can say now this is our GAN. So the GAN is complete. The GAN is the part, like two things. If we describe discriminator and generator, we will get a GAN. So here is the GAN model, and this function takes discriminator and generator. And first discriminator dot trainable is equal to for, we are not going to train the discriminator first, we are saying false. We are simply going to train the generator. Here generator is taking the input, and then we pass that input to the discriminator that generate, like when we run the generator, when we run the generator, it generates some data like this one, and it goes to the discriminator. If you can see, that goes to the discriminator here. When the generator generate x value, x data, it goes to discriminator, and then that will compile as a model. Gain is equal to model input is equal to gain input, that comes from gain input, the original input, and the output is gain output that comes from the discriminator, if you can see here. And then we run this cell. So after that, so here we are going to plot something here. So if I run this one, let me run this one. So it will, so first if you can see here, so we are going to train the model. So if you see here epochs, this function, it's taking epoch generator example 100 dimensions and figure size. So noise means basically we are generating some random data for the generator, and generator image dot predict is equal to noise. So after that we are reshaping into 228, because ImageNet dataset, the dimension was previously 784 to 28 multiplied by 28, we have 784, and the example we are taking is 100 examples. And before that, like random noise was generated with, like random noise means that this input, the random data was generated, and the generator is, we are calling the generator. Here is the generator. If you can see, where is the generator, it is going to pass to the generator, and then so on. So when I run this cell, so it's, so here is, we defined 4 functions, and after that, so 1 2 3 and 4. So after that, so here is the training cell. So I'm just simply gonna copy this function up to here. So I'm just gonna paste it here. So simply mention that training. So here is the training epochs we are taking as a 1, and batch size, let's suppose we are going to take an epoch is equal to 10. So we are going to train the model for 10 epochs, and batch size is 128. Yeah, that's fine for us because the data is too much. And then here we are defining the data set again. So here is the generator, create generator we are calling. Here is the discriminator we are calling. Here is the GAN we are calling, that passing these two things to here. And here the epochs are running and show the results. And up to here, TUKDM is library that we were talked here. So that's will show the bar, the percentage, like while training the model. And here is a random noise that we are generating, and that noise will gonna pass to the generator for a prediction. And then image batch size, get a random set of real images, and construct different batch of real, and this one it will construct the different batches of the real and fake. And after that, label for the generator real and fake. So pre-trained discriminator, so pre-trained discriminator on the fake, if you can see, train is equal to true. This time uh, we are training before, if you pre-trained discriminator on fake, and then before training the GAN. So mean that we are using the train, we are using the discriminator that know about the data set, nature of the data set. That's why we mentioned true. And after that, tricking the noise input of the generator and discriminator and so on. And we are describing the discriminator is equal to 5. During the training of the GAN, the weights of the discriminator should be fixed, and we enforce that setting here, and so on. So if I run this code, so after that, just simply uh, training the model here. So you can also put 1, it's up to, yeah, 10. The minimum by default we have a 10, and I'm just going to run for the 50. So let's see if I run this cell. So you can see here how the code is, it's showing me the bar here. So the progressive bar, why it's showing me the progressive bar? Because of this TQDM. So where is the TQDM? Yeah, this one. It's work on the base of batch size, that is 128. So we are using 128 also. So we'll have to wait here and see the results, how good the results are that model perform. So I'm gonna pause this video and then we'll show you the results. Here the model has trained on 50 epochs. So here you can see the results. So here is the results that model generate after these epochs. So here you can see the initially how much the result model generate, and then go on. If you can see here, we also save the results here. Here is the result that model generate. So these are not so good. So you can also, if you can see, try to generate like 2 2 something like that, and you can see how much the accuracy model improve. You can also see. And if you're gonna train the model with different epochs and try to enhance the accuracy, you can do it. So the model will give you, you can run the model up to 500 epochs, and the batch decrease the batch size, and do some further alteration with the model, and improve the layers and something like that. So this is basically a concept of about how the discriminator and generator work. So you can, hopefully you can get a good idea, and you will try to build your own generator and discriminator model for your own problem. Thank you so much for watching this video.